and that we find out using different metrics like the determination coefficient. Now, when we have a set of data and we are using a statistical fitting method for model generation, and we'll be able to calculate the predicted values or calculated values. So in that case, we can find difference between observed values. This is called, if we are in set, it's called training set. In that case, some of the residual values will be positive and some of the residual values will be negative. So if we take sum of those, we will get 0. So if we take square of that will not be 0. So our objective is to minimize this sum of squared residual. And it is important for us to use some also for comparison. The value of the this is the reference, because in this case there is no model. We are comparing our objects with the we are not using any model. So if we take in a similar manner the difference between the individual observed value and the mean of the training set, and take square of that, and if we take sum of these values for all the training compounds, so we'll this value. Now you see the numerator and also the denominator. Obviously, the numerator should be the small value. We aim at giving him all the square result, and obviously value, because here we are not using any kind of modeling technique. We are just using mean of the trade compounds as our reference. So this difference should be high for many of the compounds. So denominator will be a high value. And obviously this ratio should be a small value and close to 0. So 1 minus this value will be close to 1. So R square means determination coefficient, that should be close to 1. And square root of determination coefficient is the correlation coefficient. But this expression doesn't tell us anything about the number of descriptors used in the model approach. It may so happen that we have 50 compounds and we have derived a model using 5 descriptors and we get R square value of 0.9. In another situation, it may so happen we have the same 50 compounds, but we have used 10 descriptors and also we have got R square value of 0.9. Now, obviously, the model with the lower number of descriptors will be preferred because both of them shows same level of R square, but one of them is using a lower number of descriptors. One number of descriptors, it is having the freedom. QSAR is a statistical fitting up to apply requirement. So number of data points should be higher, descriptors should be lower to have a statistically meaningful model. So if we use explain various expression, you will see we have the number of compounds N here and number of descriptors P here. And this number of descriptors penalize R square value. So if we use more number of descriptors, the R square value will be penalized and it will be smaller value. So when we use R square or adjusted R square, so this is a better reflection of the model quality because we are using both number of compounds and number of descriptors in the expression. We have also another metric, that is variance ratio, that gives us information on the stability of the regression coefficient A1, A2, A3, etc. that we have derived in our model, and the correlation coefficient that we are in. So you can see at the expression numerator we have this calculated value on the mean of the training compound in the square form. We take sum of those and it is divided by the number of descriptors, and in the denominator we have and we have the error of estimate, that is root of squared the degree of freedom. The standard estimate should be a low value and variance ratio should be a higher value, and F value should be significant at a particular degree of freedom, and F will have 2 degrees of freedom. This is the statistical test for a regression-based model. Doing QSAR as a statistical modeling approach. But this, the previous metrics do not say anything about the quality of predictions. To know the quality of prediction, we have to use different metrics, either external value. In prediction, we use the same set of compounds development. We mix some of them from the data set, from the training or modeling set. From the reduced set, we redevelop the model, and from the model developed from reduced data set, we predict the omitted compounds. And we do this in cyclation. Leave one in each cycle, we can remove one compound. In case of leave many out, we can remove say 5% or 10% or some percentage of compound. In that way, we will have the predicted values for all the compounds, and then we use the similar kind of formula that we use. The only difference is that here we are using either leave one out or leave many out predicted values, and we this metric that Q square or cross variated R square should be higher than 0.6. Not set of data set of data which may be completely external data set, and then we compare the data the observed values, and here also the mean of the training set compounds, and the expression of R we are comparing it with mean. It should also be higher than 0.6. And we have other method of validation also, like bootstrapping and wide randomization. So this validation approach is equal to QSAR, and this validation we get the predictions. It may have from read across. The same formula you can use for read across also. So in case of QSAR model development, we have these general steps like data preparation, where we use the logarithmic transformation of biological activity values as our dependent variable, and we calculate descriptors from molecular structure. If derive the QSAR table, then we process the data using data pretreatment, because they are interpreted descriptors or noisy descriptors. We have to remove them. Usually, we partition the data set into two parts: training and selection and model generation. And then we use this model for the data taking off. We have for quality of the statistical model obtained, and also we have to check the quality of prediction either internally or finally use this data. So this is in short the steps for QSAR model development, and this also with the way there are 5-point guidelines for QSAR model generation. So all these steps are in the OECD guidelines. And there are also some specific points which one should consider during QSAR model development, like say data homogeneity, like when one is collecting data, all the data should be from the similar experimental protocol. Inappropriate endpoint data should be avoided, like say biological activity data should be taken in log scale, and the activity values are taken in the form of required concentration. That is the concentration required to elicit some response like EC50 or IC50, and that should be in the molar scale. We should avoid using incomprehensible descriptors. The descriptors without having physiochemical meaning should be avoided. The error in descriptor value, sometimes error may occur during descriptor calculation using some software. Some software is unable to handle some specific molecular feature or some element like say iodine or some metal, etc. In those cases, some wrong descriptor values can be calculated. So those should be taken care of. Transferability, the model that is being generated should be transferable, reproducible by other groups also. The applicability domain should be checked, because the model that is generated should not be used universally without using the domain of applicability, because QSAR is based on similarity principle. So the query compound should be similar to the training compounds. Anachronisms may not be fitted with the model, and they may be outliers. So if they are removed, appropriate reason should be cited.